All right, welcome back, everybody. Um, gonna do the next part of the video here, and there's a few things that I'm gonna do in this video. I'm gonna start by going over a couple bug fixes, so some things that I've seen in the comments that have been happening, a couple things that I found myself that I'm sure other people have come across, um, and then we're gonna add the move log onto the side of our board. And then we're going to try to improve the AI a little bit by making it consider positional advantages and things like move priority to make our alpha beta pruning algorithm a little bit better. It's still not going to be really fast, and there's some limitations. And so I'll talk about those, and maybe some potential improvements beyond that. But so one of the first things that I think I fixed in the other video, but just to show that again is, um, let's say we have a board like this, um, where, oops, I think that some people were saying that a bug they found is that the king could castle queenside when the knight was there. And so our castling algorithm has to make sure that this square is empty. So I think I showed that in the last video. One of the bugs that I think some people have been having is with enpassant. So I'm now using the advanced move algorithm again. So I have that version of it running. So I can capture enpassant here just fine. I the animation's a little bit weird. So like notice how when I capture enpassant, the piece actually moves. So we're gonna fix that. So the piece stays here and then is captured as opposed to like moving. But the other thing is, let's say that I make a different move as white, but then I undo that move. Notice that my en passant rights did not actually correctly come back. So we're going to fix that bug as well. So two things with en passant. Um, here was the other castling bug. I remember. Let me just make some weird moves here. Okay. So if our rook gets captured, the other castling bug was that black could castle and it would switch places with this piece here. Um, so I think in one of the versions of the video, I forgot to actually implement this. And in this version, I do have it implemented. So another possible bug that people were having was actually being able to castle while that rook had been captured. Not when it was moved, but when it was captured. So I'll show where that is as well. All right, so let me go through a couple of these bugs and the fixes of them. For this here, in some of the other videos I had from import, from like some file import. This just depends on your project directory. Now, for some reason, like PyCharm doesn't really like project directories very much. So like, even though these are inside of a certain project, like, and they're all in the same folder. All of these are in the same folder here. It does not like it very much, but it runs just fine. So if you get some red underlines under your imports, you can just ignore them. And when the code runs, it should interpret it correctly and it shouldn't give you any issues if they're in the same folder. So I wouldn't worry too much about that. Okay, so let's start with the castling stuff first. So I'm going to go over my engine and show you guys where this castling stuff needs to happen. So the first thing is dealing with that the castle over the knight. So let's go down to our castle moves here. Under queenside castle, I think the only issue was I had accidentally left out this equals equals in one of the versions of the code. So just make sure in your queenside castle moves that you actually make sure that this C-3 cell is empty. Uh, I think I think in the version of the video I just had that, which is causing the bug. Now we want to fix the castling rights for when a rook is captured. So in the update castling rights here, I have if the pieces if the king moves or the rooks move, then that sets the appropriate rights to false. But I also have this piece of code here, which is when the rook's captured. So if you can still castle with a rook that's been captured, this might be why. Again, I might have forgot to put this in the video when I did castling, just maybe had it in one version, didn't in the other. But basically, you're just checking to see if the piece captured was with the rook, and if it's the rook and its end row or end column is a certain point, then we set those castling rights to false for the appropriate one. So you can fix that bug as well. So I think that should fix all the castling bugs. The en passant is kind of an interesting one because it sort of works, but it doesn't. And part of it is this en passant possible idea. What I think is a better way of doing it is kind of like we did with the castling rights and creating a castling rights log. Because then all we have to do when we undo the move is just grab the last element from the list of en passant possible. And we're going to start to see that, like, as our state changes, as our game state changes, like, we're keeping track of a lot of different things in lists. And it might be better to actually just generate a state list. So it's not something that I'm going to do, but it's an idea that I had where this game state class, we could just create a list of game states. And then we wouldn't really need a move log anymore because we could just look through the game states moves. And like each game state would have its own set of moves that corresponded to it, which would also make for like transpositions would be a little bit nicer because like if we reach the same state that we've already reached before and we've already calculated the moves, we wouldn't have to recalculate those moves. So it's something that to make the AI faster, to make the program, the engine faster in generating things that might work. I haven't tried it out yet, but definitely an idea that some of you might want to try if you feel up for it. So for now, to fix this bug, what we need to do is to understand where it's coming from. It's in the fact that when I undo a move, if I undo a move that's not en passant, for example, like the only time I give back the en passant rights is if the move was an en passant move that I undid. But otherwise, like when I undo, like let's say I move that knight and then moved it back, I had en passant rights at that time, but when I moved the knight, those got erased and weren't saved anywhere in memory. So I couldn't bring them back. So we're going to implement it somewhat like we did the castling rights here. Okay, so let me see here. Let's start at the top. What I'm going to do is I'm going to modify this a little bit. So I'm going to take the en passant possible here, and what I'm going to do is I'm going to create an en passant possible log, and I'm just going to put the first entry in here. So like the castle rates log. And what we'll essentially do is like every time through, when we make a move, we just add the en passant possible to this list. When we undo the move, we just remove it and grab the last one. And so this is going to make it a lot simpler. So I can get rid of a lot of the logic that we were trying to use before. So we still need to keep this logic in here, right? We still need to enable en passant when a pawn moves twice. So the make move logic is going to stay the same. The only difference is we're going to go ahead and add in. I'm just going to add it somewhere in the make move function. Enpassant possible log. I'm going to append the new enpassant possible. So they're going to be an empty parentheses, or it's going to have the square that we can move to. And now the undo move we can simplify. We can simplify the logic here. I no longer need to do this part here. And this, in fact, doesn't work in all cases. So I can get rid of this part. I still need to undo the, so like I still need this part, but I don't need where I'm setting that variable. And I also don't need this part here where I undo a 2-square pawn piece, because I now am keeping track of what the state was previously, so I don't need to recalculate it. So I can just get rid of those 2 lines of code and replace it with a very similar log. I'm going to take the log and I'm going to pop off the last element, which is the rights that are no longer relevant because we undid the move. And then I'm gonna set the current possible equal to the last element in our log. So same idea as the castling, we'll go to -1. I think that's it for enpassant possible. Oh, yeah, make sure you have this in here as well in the undo move. Self checkmate is false, self stalemate is false. I think that was a bug fix in another video. But that changes the state back in case it lets us undo checkmate and stalemate moves. Otherwise, we will not be able to undo them properly. Okay, so I think that should be it. So let's go ahead and test it. I'm going to go ahead and run my main. And let's see if we can get an en passant here. All right. So capture works fine. I undo it. It still works fine. I do a different move. I undo that move, and now the rights maintain. So it looks like it's working a little bit better than it was before. All right. So that is one of the bug fixes that I wanted to do. Yeah, like I said, we have a lot of these different logs. So I think potentially making like a state log where each one just like grabbed. So instead of grabbing the net, like when we undo the move, we would just revert back to a previous state of the game as opposed to sort of modifying all the variables individually. And it might make things a lot cleaner. One of the problems with building an application the first time and not thinking through and then like adding features onto it whenever it's a pretty clunky application at this point, is we start to run into problems like that where it's sort of like it works, so let's just leave it. But you could definitely try and implement that if you'd like. I think it would be nice. I'm considering doing it, but we'll see. Okay. So the next part of the video here, I'm going to go ahead and add in a move log. Oh, wait. Before we do that, let's fix the animation. So the en passant animation is a little bit broken. So we're going to fix that part. I'm going to go down to animate moves in my main. And here we need to fix basically this n square for the case of an en passant move. Because this n square is where we draw the piece captured here. And so here we're going to make sure that if the piece is captured was an en passant move, then we need to edit it and we need to change the n square to be the appropriate n square. Okay. So what we're going to do is add in another catch if statement here, and we're going to check if the move is an en passant move. So we should have, let's just verify that we have that field. in our move class. Yeah, enpassant here. So this is going to be true on an enpassant move. So that's what we're checking here. So all we're going to do is say if move is enpassant, then our n square is going to change. Now, the only difference is that the where we draw the piece that's being captured, we draw it one square down if it's a black pawn being captured, or one square up if it's a white pawn being captured from the n square from this variable here. So what I'm going to do is I'm going to calculate the new en passant row. So this is going to be where we draw which row we draw the piece in. Now we're going to use the conditional if statement. So en passant row will be move end row plus 1 if the piece captured. We can't do like game state white to move in this method because we don't have access to the game state. We didn't pass that in. We could, but since each move keeps track of the piece moved, what we can do with that is we can just look at the color of that piece. So if I look at the piece moved captured, or sorry, I could either look at the piece moved or the piece captured. So if the piece captured is a black piece, then I want to let me display this here. Second, give you a visual. Okay, so here we go. So the piece being captured is this black piece here. So if the piece captured is black, this is row 0, 1, 2, all the way down. So I want to display that piece instead of on the end row, which is row 2, I want to display it on row 3. So if the piece captured is black, I want to add 1 to the row to show that it's en passant, or I could just set the row to 3, since it's always going to be captured on the same row. And then for black capturing en passant, we want the white pawn to be down like closer to the top, so minus a row. Remember, we're counting the rows starting at 0 at the top of the screen. Okay, so uncomment this. If the piece captured was black, add 1 to the row. Otherwise, we do move end row minus 1. I don't need parentheses here. So the en passant row is going to get changed from the old end row, which is this move end row. And then what we're going to do with that now is we're going to recalculate our n square. So I'll start and I'll just copy and paste this line of code from here. So instead of n squared being a rectangle that's our move end column, move end row, we're going to change this now to be our en passant row. All right, so now where we draw the piece, when we put the piece on to this n square, it's now based on this new en passant row as opposed to the old n square here. And that should fix the animation bug that we had. So let's test that. All right, and notice now the piece stays in its position until the animation finishes and then it gets captured, which is how the other animations work as well. Okay, so that is some bug fixes so far. Now on to the good stuff. What I want to do next is we're gonna add in a move log. So I would like kind of something like here. I'll show you kind of our end goal here. So here, when we run it, it's going to display the moves on the right hand side. And I'm playing against an AI here, so it played e6, and then knight f3, and it played knight c6, and c bishop e3. So we're going to get that move syntax here. It played queen f6. Okay, so that's what we're going to implement next. And I'll show you guys how to modify this if you want to make it a little bit larger, if you want to make the font a little bit bigger, how many moves per row you want to put in, and we'll go through the logic of that. Okay, so what I'm going to do is I'm going to take this text method and I'm going to just rename this because we're now drawing more than just the end game text. I'm going to define this draw text method as draw end game text. And then I'm going to keep this exactly the same as before, but I just wanted to rename that so that we can use draw text to be more meaningful. We're going to specify that as all. Okay, now we can clean up our code as well in the main. So here, instead of like calling this function 3 times with a different string, you don't have to do this, but I think it's kind of nice. What I'm going to do is I'm just going to make a variable called text and have this be the string here. Same thing with this one, and same thing with this one. And I'm just going to reorganize this a little bit. So I'm just going to say if game state is checkmate or stalemate. So I'm going to combine both into the same here, so that now we're checking both cases, and then game over equals true. And then here I'm just going to say if game state is stalemate, then I'm going to put my text equals stalemate here. And then if otherwise, if it's not a stalemate, then we'll check these guys here. And I can simplify this conditional here in the same way that we've done before. So we can say text equals basically this part here. So text equals black wins by checkmate. If game state white to move, else white wins by checkmate. And I could do the same thing for this as well. So I could chain these together. We're just going to simplify this again. Text equals stalemate. If game state stalemate, else black wins by checkmate. If game state white to move, else white wins by checkmate. Okay, so that's just like simplifying the logic, making it look a little bit nicer. With that big block of code, now it's down to 1, and all it's doing is setting this one field, and now we can call our draw in-game text with that. And if you want, you could put all of this into that parameter, and we could get rid of that field altogether. And so now our just code is like a little bit more streamlined. Okay. I'm gonna add in. I'm gonna kind of organize these methods here. So since the game state is what calls the other ones, I'm gonna put this one first. Just an organizational thing. And then I'm gonna call these in the order that, or I'm gonna put these in the order they're called in. So drawboard is called first, so I'm just gonna move drawboard up here. So it's drawboard, then highlight squares, then draw pieces. I like to organize my code this way. It helps me to find methods a little bit more quickly. And then this animate move and draw game text are other methods that are called from within here. Okay, let's Now, when we want to add to our game state, after we draw the pieces, we can now draw our move log. So this is going to be our next method, and it's going to take a screen, a game state, and then I'm going to create a move log font. And I'll pass this variable into this function here, move log font. Okay, so we're going to write this method here, draw move log. So it's going to be underneath pieces, just so I can find it. And again, if you're done writing methods, you can collapse them. Shortens up your code a little bit, makes it easier to see what you're working with. Okay. So I'm going to put this in between these methods. All right, and it's going to take a screen, game state, and a font. Write pass in there for now. Write a little comment. Draws the move log. Okay. So let's grab the font stuff from here, from the text we already wrote, and let's start with that being our method. Okay. Now, I'm going to obviously modify this a little bit, but I wanted to just get the basics of what we have. So we had our font, we had our text object, text location, and a screen blit. So this font I'm going to modify. So here, instead of loading the font every time we draw the move log, which is going to be like every frame, we're going to load it once at the beginning and save it in a variable called move log font, which is going to get passed in through the draw game state function here. So we're going to add that call here, move log font. And so here, I'm going to just define it right here outside the while loop. So it doesn't really matter where at this point. Again, our class is getting kind of messy. There's a lot of fields here, and it's maybe requires some reorganizing, but it's all right. All right. We can just define it up here, and I'm going to call this move log font, and this is not going to be size 32. We're going to make this much smaller. I'm going to start with size 12. And I'm not going to make it bold or italicized, so I'm going to set those both to false. And I'm going to use a different style. I'm going to use Arial, but you guys can pick the font that you want. And this will be the font on that right-hand side. So if you want to change the size of it, it's going to be changed there. Right? And then that gets passed through. These are all our events. I'm going to actually collapse some of these. This is our AI move finder. This is if the move made. And then here we draw the game state and pass the move log font here. Okay. And then that's going to get passed all the way through, and that's what font is going to be equal to. Okay. So now we have our font loaded in. We don't have to do that every frame, which is nice. What I'm going to do now is I'm just going to add that side panel onto our board so that we can see where we're going to draw the text. So for right now, let's go ahead and comment these out. And let's create a rectangle object, a Pygame rectangle object that's going to represent where we draw the move log. So I want this to be on the right-hand side of my window here. Right? I want it to be right here. So I need to define, I already have this width defined. I need to define another width here, and I need to modify the Pygame Windows screen. So up here we have a couple variables here. We have width and height. I'm going to just make these more specific. So I'm going to go ahead and refactor these. Right-click, refactor, rename to board width, so I know what I'm specifying here. And I'm going to refactor this to board height. Again, just so we're more specific with what we want. Now, the move panel, so I'll call it a move log panel, will also have a width. And this I'm just going to set to be, like 200 was like a little bit small, and I think we're doing slightly bigger fonts. So I'm going to say 250. We can adjust this later. And then the move log panel height, I'm actually going to set to the height of the window so that it expands the entirety of that right-hand side. So these two variables are going to define that black rectangle that we saw. And so now what I need to do is when I load my board in here, that's this method here. This is what actually defines our window size. We say board width, board height. I'm going to add the move log height. And just look what that does right away. I might get an error actually, because yeah, hold on a second. Let me get rid of that. All right, so see that, ooh, I did something wrong. That's more than 250. But notice how I have now a larger window to work with. It looks like it resized on my OBS as well. So like it's kind of smaller, but like on my actual window, the board hasn't changed size. So I can try and resize that. Give me a second. Okay, that should be good now. But yeah, let's figure out why that expanded so much. I don't think I meant to do that, but I must have had a typo already. Yes, I said board width plus move log panel height instead of move log panel width. My fault. All right, now it's a little bit too big. Okay. So now we've got the panel here on the side that's 250. I immediately got an error when I clicked on that panel. And this is something to consider because remember when we do our mouse clicks, we got the mouse position X and Y. And here it tried to highlight a square that wasn't on the board, list index out of range. So what happened? In our events here, we say location of mouse equals XY. The problem with this, by saying column equals location 0 square size, location 1 square size, is now the row and the column can be larger. Let me just show you guys. Well, not the row, but the column can now be larger than 8 or 7, if you will. So I'll just do some clicks. So if I click here, see how it prints out 7, right? 6, 5, 4, 3. But if I print out here, it's 8. And so it's trying to highlight a cell. Well, here actually it tried to look at a move with row or with column 8, and that doesn't make any sense. So what we need to do here is add in a little check so that when the player clicks, we check to see if the square selected is row column. So this is for deselecting. I can just add another condition here to deselect, which is if column is greater than or equal to 8. So I'm just going to put the user click the same square twice, or user click the mouse log. So we just add in that little logic. So all just that fixes it. And when you're trying to like implement a new feature like this and you realize like that it messes with your old code in some way, always try to think about where the source of that bug is, right? The source of that bug was all the way up here where we generated the column number. So I don't want to go ahead and like put a check in everywhere else and like make sure the column is greater than or equal to 8. I want to check it as soon as it happens so that I can make sure that my program is in a valid state. So as soon as we set that column to 8, we're gonna make sure that we do nothing with that. We reset the player's clicks, we reset the square selected. So what this does now, which is nice, is so if the user clicks on a cell and then clicks the move log, notice it deselects that square and it doesn't bug out. So now if they click over here, it's like resetting it. It's the same as clicking a piece twice. Okay, so now let's get into the actual drawing of the panel and then the text on that panel. And the logic in this is a little bit heavy. And I'm going to do it with for loops, but I think there's better ways of doing this, maybe with like using like a library called itertools. So if it, I'll show you the basics of it, but like I think there's ways of simplifying the logic here with other more advanced libraries. But we'll do it all with just for loops and if statements, and it's kind of a fun little exercise. So all right, so here we have the screen we want to draw on, the game state, which is going to give us the move log itself, and then our font, which is what we're going to use to actually draw the text. So back to this line of code, move log rectangle equals. The rectangle that we're going to create is going to be starting at board width. I want it to start all the way over to the right of the board. So this is my x coordinate. If I put 0 here, it would actually draw the panel over top of the already existing board, which we would not want. I'll show that just so hopefully you can understand this. So these are the dimensions we want to use for this rectangle. And then I'm just going to start by drawing the rectangle with a black color. And if you want to do a different color, you could say blue here or whatever. I'm going to do a black move log with white font on it. But if you wanted to do, blue with red or I don't know, whatever funky color combos you like, go right ahead. All right, so we're just going to go ahead and draw that on here. And we should now see that it's black, which is what we want. What I was saying here is if I had made this 0, then notice how it's on the left, it's overwriting this. So we could have something like this that's like kind of like a pullover menu and maybe, leave our board, have like a little bit where we could like click on this and it would have like a pop-out menu, something like that. I might do that later on. But now we want this rectangle to start at board width. We want it to start here in the X. So that's why that's why we have board width there. Okay, now I'm going to go ahead and grab my move log so that I can get the moves. So I know what I'm actually writing. And here we're going to go ahead and create a list of the move texts. And what I'm simply going to do is I'm going to go through the move log, which is actually, I think the move log is a list. So to start off, I'm just going to actually set this moves text equal to move log. And then we're going to later go in and grab these strings and convert them to like better chess notation. All right. Now I want to draw multiple text objects down the move log, and I'm just going to start by drawing one move per line. So what I'll do is we'll start with a for loop that goes through for I in range length of move texts, which is also just our move log at this point. I'm going to now put in these lines of code. So render the text object, render the location, and blit that onto the screen. The text here is going to be represented by move texts I. Like I said, we're going to modify this later. That's why I'm putting that in there. Then we render the text. We pick the color. So I'm going to pick the color being white this time. I'm going to turn on anti-aliasing. I think this true. I actually, it could be true or false. False will be like a little bit worse in terms of how it renders. Maybe we'll leave it as true. And then the location of this. So here, what I'm going to do is I'm going to set the location to my move log rectangle. And then I'm just going to move it by a certain amount. So I'm going to create this padding variable, which I'm going to set to 5. And so I'm going to just move it 5 to the right and 5 down, and I'm going to blit it there. Okay, so let's just see what happens now. Let's see what we get so far. All right, so, all right, error. Text must be Unicode or bytes. Maybe we need to say string, since it must not be. Oh, right. Move text is a move object. And the move object does not have, we could say move.get chest notation. That's what we should say. So .get chest notation. I don't think we need the string here, because that should be returning a string. Okay, so now we see that E2, E4 appear there, and then notice how the text is overwriting, because I'm not changing the location. So I'm just blitting all of the text objects on the same part. So to get them to the text to draw like straight one down from the other, what we can do is we can define some variable. I'm just going to call it text y, and I'm going to start it at padding. And I'm going to move down by a y variable of text y. And then each time through my for loop, I'm going to say text y, and I'm just going to add the height of my text object. And then if I want some spacing between my lines, I can add that here as well. So now if I add that in, my move log will look like this. Make a move. Now the next move appears down there. Next move appears down there. So I'm getting a move log here like so. I'm just outputting that. Same stuff that was put in here. Okay. So if I want to put a little bit of line spacing between here, I can, make a variable called line spacing. And, I can just make that like 2 pixels or something like that, something small, but it'll add a little bit of range between these values, between these rows. Now, what we can do next is get this to show up in terms of like turn and have a couple appear in the same row, because right now it's just one move per column, or one move per row, and then it immediately moves downward. And so what this is going to require us to do is grab the move from the move log and then essentially build a string out of it. So I basically want to combine these two strings. If my first 2 moves are these 2 moves, so for example, if I have F2, F5, and then I follow by F5, F2, what I want to appear in my move log is something like this. 1 for the move turn, the turn number, and then the first move, and then the second move, and then a space, and then I want my second move to appear there. So I want something like that. So what I'm going to do is I'm going to now this is where we're going to generate this move text. So let's start by having an empty list. And what we're going to have to do is go through our move log 2 at a time. So I'm going to use my range function, go through the move log with 2 at a time, every other one. And I'm going to create a move string. And my move string is going to be the number, the turn that we're on. Now, I right now is going to start at 0, but I don't want it to be turn 0. I want it to display as turn 1. So I have to take I and I have to add 1 to it. And that's going to be my move string. So this will give me 1 for the first one. Then when I is 1, it'll give me it will give me move 2. So it'll just go through like that. Now here's the problem though. When I get to like move log 4 in there, I want it to be only turn 2. So like the 0 to 1 conversion works for like the first instance of it. But like think down the line when you're on index 4, this actually corresponds to move number 3. So just to try to put this into, I don't know, I'm just going to make up some words here. E7, E5, E2, E4, whatever. I'll just repeat. All right, so whatever they are, let's say this is what I want. This corresponds to index 0. This corresponds to index 1. So 0 and 1 count for move 1. Index 2 and 3 count for move 2. Index 4 and 5 count for move 3. So just doing I plus 1 doesn't work, because when I'm on index 4, I really want to subtract 1. When I'm on index 2, I want to keep it the same. So the mathematical function is actually I divided by 2 plus 1. If we do 0 divided by 2 plus 1, we get 1 again. If we do 2 divided by 2 plus 1, we get 2. And if we do 5 divided by 2, we get 2 plus 1 is 3. So we divide the move number that we're on divided by 2 and add 1. That's going to give us the number that we're going to put in front of our string. So I'm going to cast this to a string. I'm going to add the period and a space. And then I'm going to finally add our move log. So we'll say, here we'll go move log I dot get chess notation. So that's string. And then I'm just going to add a space at the end. So that's going to be my move string. Now I want to make sure that before I try to add the second move to this, I want to make sure black actually made a move. So I don't want to access something in my move log that doesn't exist. So I'm going to make sure that if I plus 1 is less than the move log length. So this is just to make sure black made a move. I'm going to get rid of this comment now. Move string. Now I'm going to add black's move to it. And this time I don't need a number because this is the second move in the list. So I'm just going to simply add in move log I plus 1 get chess notation. All right, and then I'm going to append to my list of move texts move string. Okay, so now I can get rid of the get chess notation down here because move text is now strings. And now let's see what that looks like. All right, so now first move is made. All right, so I've got the number 1 here, and then the move, and then the second move is made, and it appends it to that string. All right, now the second move, third move, third move. Okay, so now we're starting to get it. Now I'd like to put a couple in the same row so that they're not. I mean, we're going to run out of space here pretty soon. So I want to put, I don't know, 3 moves on a row. So that's going to be the next thing we added. So let's figure out how to do that. Moves per row. Let's just say we want 3 moves per row. And you can change this variable if you want more. And now, instead of going through, so here, when we go through I and range of our length of our move texts, here, we're going to go by the moves per row. So I'm going to look at 3 in a row, or 2 in a row, or 4 before moving on to the next one. So here's the thing. I can't just say text equals moves I. I need 0, 1, and 2 all to be grouped together into one string. So this is where, like, again, like an iterating, the iter tools has a group function that would like kind of chunk these things together that could work nicely. But I'll show you how to do it with for loops. It's kind of an elegant solution, I think. It's kind of nice. Instead of just grabbing one here, we'll build our string as we go. And what we're going to do is we're just going to do another for loop. I'm going to use J. And here, I'm just going to go in range moves per row. So here, I'm going to execute this for loop 3 times. And I'm just going to make sure that if I plus J is less than the length of the move texts, so I'm going to just make sure that, I'm still within the bounds of the move texts and I can access move 1, 2, and 3, then I'm just going to go ahead and add move texts I plus J. So think about this. I is going to start at 0. J is going to start at 0. So there's going to be 0 plus 0. And it's going to grab the first one. Then J will be 1. And it's going to add 0 and 1 together. And it's going to grab text 1 and concatenate that to the string text. Then it's going to do 0 plus 2 and concatenate that. So it's going to do the first 3 moves all together. And then it's going to print those out. Then when it gets to 4, when J gets to 3, which is our index 3, our 4th element, then it's going to repeat back. And now I will be equal to 1 and J will be 0. And so then it'll grab that text. So yeah, let's test this out. Sorry, I won't go to 1. I was like, that's going to give us an error. I won't go to 1 because we're iterating by moves per row. So I will go from 0, and then in this case, it'll be 3. So then we'll have 3 plus 0, and we'll access the 4th element. All right, so now we have D2, D4, D75. All right, 1, 2, and then this will be the 3rd move, 4th move, and now it's on to the next row. Okay, so now we can see our move log is being built up. So again, you can adjust this if you think you should fit 4 rows per, like maybe, or maybe you make your font a little bit larger. But that's basically how to do the move log piece. What I want to do now is just make these strings nicer. So like this isn't actually proper notation. Here we're just doing like the squares that they moved. But like when you move a pawn, the notation is just to name the pawn and what square, what row you moved it to, what rank you moved it to. So like we wouldn't say D2, D4, we would just say D4. And then like for this G1, G1, F3, which is this knight moving from here to here, we would just say knight F3. So the piece and then what square it landed on. All right, and so here I'm going to also teach a concept known as overriding, which is a revisit from when we overrode the equals method. We are going to override the toString method. So I'm going to do __str. So this is overriding the string function. And we're just going to make it so that when the move itself has a string that represents it, and we'll make it more like chess notation. Okay, so there's a couple special cases of move notation. So one is like a castle move. If you're familiar with chess notation, then a castle move looks a little bit weird, but basically if the move is a castle move, there's two possible notations. It's either O capital O, and this is a kingside castle, and queen castle O dash O dash O. So what we're going to do here is give some more space. We're just if it's kingside castle or not. So we're going to just return if it's a kingside castle. So we're going to return O dash O if the end column of the move is 6. This is the column to the right. Again, I'm assuming, we're looking at from white on the bottom of the board like we've been doing all with the entirety of our engine. If we actually want to flip the board, like flip the colors, we wouldn't want to change where the pieces are in the array. We want to change how we draw it. But yeah. So we'll return kingside castle if the end column is 6. That's going to be 2 squares to the right of the king. Otherwise, we return our kingside castle. Okay, I'm going to go ahead and put this. So that's for the castling move. Moves are pawn moves. Those act a little bit differently, and then there's piece moves, and then there's also captures. I'm not going to do checks or checkmate in proper notation. When a move delivers check, you get a plus at the end of it. When a move delivers checkmate, you get a hashtag at the end of it. This ends up being a little bit more difficult, and since our moves don't have whether or not they're a check move or not, we don't have that as a flag. We'd actually have to look at the game state itself to see if it's in check after that move is made, and then add that to our move log. So where we would maybe put that is like, I don't know. We'd probably put it like when it's in check or something in our engine. Like we'd have to put a flag on one of our moves that's a check move or something like that. But I'm not going to do that part. The other thing that our notation is not going to get is like if two pieces can move to the same square. So for example, this happens with knights a lot. Just make some moves here. Oh wait. Okay, yeah. Right now, this knight can move to this square, or this knight can move to this square. So if I just say, like, this is more descriptive, B1, D2 is more descriptive because it tells me the piece that moved. But if I just say knight D2, which is the actual notation, the question is which knight moved to D2. And so what the notation is you'll say which, since they're on different files, we would use the file. So we would say knight B to D2. Knight B D2 would be the notation. This would require us to look at all the other moves to see if any similar piece can jump to that same square. And again, if you want to try this, if you want to try and implement that, go for it. But it's a little difficult, and so I'm not going to put it in the video. We'll just say knight d2, and then it's not 100% correct. We'll just say that it's just not 100% correct, but it's okay. Or you could leave it like this. You could leave it in this notation as like knight b1 d2. Like you could leave the entire chess notation, so exact if you want it to record where you can tell the difference between those two. But yeah, basically what you'd have to do is you'd have to look through the other moves and figure out where, or like, yeah, anytime you make a piece move, you'd have to see if like the other piece of that type could also make that move. And then you'd have to modify the string. Like I said, I'm not going to do that. All right. But what we are going to do is just kind of get that a little bit nicer notation so we know which piece is moving. So what I'm really concerned about is the end square. I don't really care about the square here when I'm writing chess notation. I just want to know where the end square was. So I'm going to use my get file method and pass the end row and end column because that's going to be my ending square. And then for pawn moves, I guess this also is going to be promotions. We could do pawn promotions here, I guess, like if the pawn move ends. I didn't actually think about that. You can add that in on. All right, so you can do that one. I'm not going to do that one here. It'll just say d8 would be like the pawn promoting, but it generally like the notation with like d8 equals queen or d8 equals rook or whatever you convert to. So, what we're going to do here is we're just going to check to see if the piece is a pawn, and as long as it's not a capture. So I have this variable here, capture, which we didn't implement yet. So I'm gonna go ahead and do that now. So let's specify if a piece is a capture move, and all we have to do is just add in a line of code that says is a capture move equals piece captured equal to an empty space. And I'm doing this after the enpassant, so enpassants will also count as captures. So now I can, instead of doing the check here, which I could have just done this same check here. I could have said if piece captured is not equal there, but now I have just a nicer field that I can use. And I only have to calculate it once when the object is created. So if the move is a capture, we can return well, let's start with the piece not being a capture. If it's not a capture, we can just return the end square because that's how pawn moves work. If it is a capture, then I need to return the starting square with an X indicating it's a capture, followed by the end square. So what I'm going to do is I'm going to use the columns to file method, columns to file dictionary of my starting column. And I'm going to add an X capture, and then I'm going to add end string and return that. So I'll leave this up to you to do pawn promotions as well. The capture will. And the other thing I'll leave up to you is two of the same type of piece moving to a square, and the chess notation indicating which one. For example, knight B to D2 if both knights can move to D2. So um, and then also adding plus for a check move and hashtag for a checkmate move. Okay. Yeah, I mean, you could. I recommend trying to do something similar to like the is capture, like calculating this if a move is a check move, like in here, maybe, or like maybe passing it in as a possible flag, like we did with castle or en passant, and then you could use it down here more easily. All right, so these are the things you can add. I'm going to do the other piece moves. And we're just going to keep the logic pretty simple. So basically, our move string is going to be the piece that we moved, but the name of that piece is the first character in that. And if it's a capture move, so again, I'm going to use this is capture field that we just created. And I'm going to say if it is a capture, let's add, and then let's return move string plus n square. Add the x if it's a capture move. Otherwise, I just put the piece with the n square. If it's capture, it's piece x n square. Okay, so when I override this toString method, what I get is now when I call the string function on a move, it's going to actually give me this result. So I can go back here now and I can modify this a little bit. And instead of move log get chess notation, I'm going to do string of move log I. So I'm not going to use that get chess notation method anymore. I'm just going to use our string function that we overrode. And then same thing for this one, move log I plus 1. I'm going to pass that to a string as well. And it's going to call that override method that we just defined. Okay. And now we should see, I'm going to change moves per row, or I'm going to actually increase the font size a little bit on my move log. So I'm going to go from 12, I'm going to go up to 14. Just make it a little bit larger. And I'll go ahead and run it. All right, so now we can test. All right, so it just says E4, nice. No E2, E4, right? E4, E5. This is knight F3. Okay. One thing, I'm not seeing a space here anymore between E5 and 2. So like that's maybe something that we want to fix. Knight C6. Bishop B5. Again, I think we want to put some space between those ones. A6, bishop A4, B5, bishop B3. So this is looking pretty good so far. And the only thing I think we need to add is like some space between these. And where was that at? So each one of these, we put a space at the end. Oh, but I forgot to put a space after the black move. So you can put 1, maybe even 2 for a little bit extra spacing if you want. All right, so let's see. That's looking pretty good. Do that, we'll do that, this. We'll castle, check if castle shows up right, which it does, that's good. Let's just check queenside castling. Make some weird moves here. And queenside castle. Okay, so it looks good. Undoes it. It erases the moves that were made, which is cool. So yeah, there's our move log. Okay. So I think this video went long enough already, so I'm going to wrap it up. And I know I said at the beginning I was going to do some more AI stuff, but I guess I'm not. I'll do that in the next one to do some like positional advantage stuff. But I hope you guys enjoyed this. I think it's a cool little feature, and then maybe this will get you started on in terms of like menus and things like that. So now you kind of see how you can expand your window a little bit and add different panels and stuff, and add objects into that specific panel. Yeah, I'm planning on implementing a menu which lets you select AI human before you start the game. Maybe doing mouse click and drag instead of having to click the pieces, being able to click and drag them. And then obviously like improving the AI a little bit. So right now it's pretty dumb. Uh, if we play against it, I didn't do any AI improvements in this video. So I think, let me see what we're running at depth 4 right now. So it's kind of slow. It's still doing the alpha beta proving. We'll do move priority, which will cut down on the ones it does, and then we'll also look at more than just material. We'll try and prioritize gaining space and attacking pieces and things like that. So yeah, but that'll be next video, and it's in the works, so hopefully won't be too long. I know this one was a long time since I recorded the last one. It was like a month ago, but yeah. The other thing, if you guys want to leave some comments in the video in terms of after I finish this, I'll probably keep doing other like little tutorial projects. So I could do more Pygame Python stuff, or I could do something with like Java FX, something in there, just little tutorial stuff. So if you have ideas for that and you want to share your thoughts, I'd love to hear, and maybe I can design something with that. But yeah, thanks for sticking with it through the whole video. This is going to be real long, so but until next time, I'll see you.